the people that are here in the room, how many of you have already seen the talk that I gave 4 weeks ago or a video of it? Quite a few. Okay, so you're actually probably here more with your angry questions you want to have answered that I didn't answer the time around. I assumed that would probably be the case, that actually a lot of people have kind of had exposure to some of the stuff. So I've refactored the slide deck a little bit, trying to get more to the point where we can ask questions and have a discussion. So I want to talk about the engineering system. I'm going to talk about basically kind of 3 topics. I'm going to talk about, I'm going to start out with a very rough description of kind of what I think an engineering system is and what the pieces of Apex are, where we're going with that, and then talk about why that we need a new engineering system, using some data to try to motivate that discussion. And then I'm going to talk about, I'm going to talk about some of the cultural changes that we need to make in addition to the tools changes, and then I'll come back to the tools again, and that will be probably the place where we can really branch into a bunch of questions for people to ask. All right. All right. So Act 1, the engineering system. All right. One of the first questions that comes up is, what is an engineering system? And I have a very expansive view of what an engineering system is. I describe an engineering system as all of the tools and all the processes that we use to go from source code to a deployed product or a deployed service. Okay, so all of the tools that are in there and all of the processes, whether they are machine-driven processes or human-driven processes, are part of the engineering system. Okay, so that's everything from, think about, I have a line of code. Well, where do I put that line of code? How do I submit it? How do I build it? How do I test it, flight it, deploy it, service it, refactor it, include it in another product other than the one it was originally intended to go in, understand how it's actually being used as opposed to how I thought it was going to be used when I build it, how to discover who has dependencies on it, etc. All of that is part of the engineering system. And I bring this up because sometimes when I talk about engineering system, or when we use the word, people think, oh, you mean build, or oh, you mean source people. No, I mean everything, the entire engineering system, about how it is that we take all of the bright people at Microsoft that are able to produce source code, either directly or indirectly through their impact on the people who generate source code, and turn that into money. That's one way to describe it. All right.
Question, Galen.
Yes, George.
Does that imply that source code comes into existence spontaneously, or does the engineering system include the transformation from ideas to source code?
That's a very good question. So George asks, does that mean the engineering starts at the point you have a line of source code, or does it include the process that generates source code? And I would say yes, it goes all the way back to from idea. Okay. Now, we can't change all of that at one time. Or put it this way, I am definitely not smart enough to think about all of that. Like when I give the first version of this talk, one of the questions we got asked is, well, what about documentation? Is it not part of the engineering system? Do we not care about it? And my answer was, yes, it is, and we should care about it. I just don't know anything about it, and so I'm not going to say anything about it. So other people are going to have to. So part of this is a recognition that as well, particularly when I start talking about cultural things that need to happen, is that I think we have a culture of wanting someone to have the right answer, and there is no one person that has the right answer, and that's something we need to embrace within our culture, is ways that allow us to learn as we go and for other people to contribute and build off each other instead of looking for one person to have all the right answers for everything. Okay. There's been a recognition at the very top levels of the company. Terry recognizes it. Satya recognizes it. I think up and down the company, whoever you talk to, everybody recognizes that we need to do something or multiple things to improve our engineering culture. And so rather than just being something that we all gripe about, Terry and Soma got together and said, let's actually do something about this. And so we created this one engineering initiative between DevDiv and OSG with Terry's sponsorship, through Henry Sanders, through Chris Broom and his triad, and also with MSR's involvement. I got invited to participate in this and representing MSR because I care a lot about how we build software. I've done a number of projects one of the larger projects I did was this thing called Singularity. We built a new operating system from scratch in managed code. It was the precursor to Midori, and it was, yeah, could we build code? I'm an OS researcher, so it was, yes, I can build a new operating system, but it was an experiment in how we actually went about building an operating system and how you did it. And so,
Galen, Jorge on the call had a question. How long has this effort been going on for?
the one engineering system since November. Okay, so we started this anyway. They got together in November and said, okay, well, let's think about both third party and first party, bring them together. And how do we create an engineering system at Microsoft, an engineering culture and an engineering system that supports reuse and sharing of code rather than islands, fosters as much collaboration as possible, removes the barriers to the engineering efficiency, and reduces as much friction to the innovation, and do this across all of Microsoft. And how do we go about doing that? So, and let's actually try to make it happen. And so Apex is the kind of the first of this initiative. Well, Apex is the effort to actually build something. Okay, so it's this combined effort, and it's intended to incubate the ideas from one engineering system by merging both the first party and the third party. So getting DevDiv and, say, the engineering system organizations out of OSG working together to produce something that's useful for everybody. And we've made the conscious decision at the very beginning that we would focus on producing something that OSG could use, that DevDiv, at least part of DevDiv, could use as well, that they would be on top of it, and that we would grow it out to the rest of the company as we moved along and as the ideas matured. And one of the questions you might ask as well, if this is about all of Microsoft, how come we don't have all of Microsoft involved? Well, one of the decisions was that we're learning, we will make mistakes, and as Chris Broom put it aptly, we really only want to take down 2 divisions of the company if we fail, instead of the entire company, okay? So if we totally screw up, at least there'll be some other parts of the company that hopefully will keep making money for a while and keep the rest of us afloat, okay? Now, so in terms of thinking about what needed the tooling and what needs to change around the tools that we use within the engineering system, I've got 5 things here to listen. So one of them is the source code. I'll make this screen a little bit bigger for my benefit. Anybody know how to make that larger?
A question just came through.
All right, fine.
Is the migration to Git still on? I've been hearing rumors it's been disbanded for Threshold.
Okay. All right. So I'm going to answer timeline questions at the end of the day. All right. I'm just going to hold that one off right now. Let's talk about vision, and then we'll talk about timeline. So the first aspect of the engineering tooling and what we want to change around the engineering system is the source code management. Okay. And these are stakes in the ground. One of the beautiful things about stakes in the ground, they can be removed if they have to be. They can be moved around if they have to. But the idea is, let's embrace a new source code management process and the tools that allow that. So the compelling thing about Git is it is a DVCS. It is a distributed source control system, which means it makes it forking very easy and remerging. It makes offline and online work very, very well. And my quick answer I usually give when people have questions about why would we want to use Git is find one of the college hires in your group that joined in the last 2 or 3 years and ask them what's great about Git, and ask them to compare and contrast with whatever source control system you're using in your team, and they'll give you the set of answers there. Okay, it allows a set of agility that we haven't had before. Okay, and when we say Git, we mean Git on VSO. So VSO is Visual Studio Online. The on-premise version of this you recognize as TFS. The architecture is somewhat similar. The implementation of VSO and TFS on-premise is different. There's been a lot of concerns. I know when we first talked about using TFS things about the scalability of TFS. Much of that has been addressed in VSO. Okay, and so our idea is that the format is Git. The tooling local tools that we use is Git, and they have a server implementation that is based on Git that runs in VSO that scales much more than you would be able to scale a single machine. but there are still challenges there, and I'll come back and talk about that. Okay. The second aspect tooling thing that we're changing is creating a new build language and a new build system. And the reason that we want to change the build system and the build language is that the build systems we use right now are not holistic. They don't actually understand an entire product, for example, and they don't understand the entire process for creating an entire product. And the best way to illustrate this for you, those of you that are familiar with Windows, is time build. And the scripts, all the post-build process is outside of the build tooling that we use, for example, build.exe and the nmake tools. And what we want is a build system that actually lets us describe the entire process of building. So everything from, I have this line of code now to I have something that I can deploy either, in a CD or in a service or something, but a system that can actually understand that full spectrum and the full complexity of that. Question.
Galen, around Domino, someone was asking, what will the Domino language or script be based on for build purposes?
So this is okay. So Domino is actually it is a new build language. It has been designed from scratch. And you should all stare at me and go, oh, that sounds like risk. And yes, it's risk. Okay, it is an experiment. It is an experiment. Good way to describe it is we know that in order to describe everything that happens in build, the existing build systems are not adequate. And there is a question of, do you have to build design a new language completely from scratch in order to get a fully encompassed build, or could you take something like MS Build and evolve it, or take something that exists out in the open source community? I think any of those are plausible. The team that was responsible for addressing the build language has decided that they're going to build their own, and we're going on that experiment right now. The build, so besides being kind of holistic, the other two qualities we're looking for in the build system are incremental build. So, and the idea here is that whenever each day as we build a new version of the product, whatever it is, the product or service, that every single file doesn't have to be compiled, every single library doesn't have to be relinked, every binary doesn't have to be relinked. You should only have to renew what's been changed. And doing that the reason we haven't done that historically within the company is that our build systems, particularly the descriptions of the builds, are not complete enough, they're not holistic enough that we can't reliably do an incremental build. And so part of this is getting a language and system support so you could actually do a reliable incremental build and have it be deterministic and have the qualities you want. And a key observation here is that if you could do incremental builds, really only build what has to be built, that you could do builds much faster. And we could iterate on the loop of, I add a line of code to this system and I get a fully deployable system out of it, and be able to take that time down significantly. Another aspect of the build system is cloud-based, so being able to use large numbers of machines to parallelize the build, so that in those cases where you actually do have to, say, rebuild every single binary product, that you can do that as fast as possible. This is one area, the build system in particular is one area where our competitors, to pick Google as an example, really are very far ahead of where we are. And much of what we're trying to do is just learn from them and acquire as many of those ideas and hold them for as we possibly can. So the next, the third kind of, yes, okay, you can ask a question.
Okay, the question is Domino going to be responsible for only building the individual units or for building the products as well?
So is Domino going to be responsible for building individual units?
Or big products,
like the entire product? Maybe I can ask it. Do you mean like, are we going to pull post-build into build? Is one way I might ask.
Define a new way of post-build.
Yes. So we are going to pull all of the post-build, all that into build. Okay. Now there are still some. The reason I hesitate when you ask that question is because I'm trying to figure out what you're asking. So if you think about Windows build, there's post build, and then there's some orchestration that you think about. Like for example, I might want to do a build and then kick off the long haul quality tests, and whether those two operations will both be inside a domino description. My answer to that would be I don't think so. Now there are people in Domino team might say, oh, we've got such a general purpose thing. We're sure that they will be. Okay, so we'll learn and we'll answer that question.
The reason behind my question is like when building a big product, like let's say it's made of 20 individual units, should I have all the 20 units in my local machine? And I build just one unit and keep combining everything, or I can pull the remaining 19 units from the cloud?
Okay, so you're really asking a question. This is the thing we call binary integration, which is when I create a product, do I create the product because I have all the source code for the product and I compile the entire, I build the entire product because I have all the sources, or do I build, say, my piece of it and then pull binaries and integrate binaries from other groups in order to produce it? And my short answer is we should support both. Okay. One of my early descriptions to me, build nirvana would be that, say, a developer in DevDiv who is responsible for a portion of the C compiler or the C runtime could make a change of a line of code and with not much more than hitting an F5 actually have their piece, the compiler piece, be rebuilt, Windows be rebuilt so that every binary had been built with that new modified compiler, and Office rebuilt with that new compiler, and run the Office and Windows BVTs, and have that all happen with nothing more than telling the computer that's what they wanted to have happen. To me, that's build nirvana. Okay. Are we there yet? Probably not.
Are you planning on describing how we got to this point? I mean, you're saying we're going to build a bunch of new tools and process, and at some point we built tools and process. Were they not maintained regularly? Did we not realize the scale?
We're getting a lot of questions in mind too about if Q was evaluated when looking at Domino. Did you?
All right. Okay. So here's what I'm going to do. Okay. We're going to come back to all the questions about the specific technologies. What I wanted to do was introduce the technologies, and I've actually talked longer than I meant to on this right now. And then we'll come back to this slide actually, and we'll ask a question. Anyway, the third component is the quality strategy. We're seeing part of this with reorganizing of dev zoning the tests and unit tests release and those being put in. But also getting to the point where when I build something, I can figure out which tests need to run and have them be run. And ideally, the machine figures out that they're being run. And be able to do this as quickly as possible in what we call an inner loop. And then the fourth and fifth component are pieces of this are around the same area. So componentization, and I'm actually going to come back and talk about a culture of componentization. But one of the things we realized actually in the last 3 months that we didn't realize initially is that when you think about componentization, which is breaking code into functional units with well-defined boundaries, is that there is an aspect of this where you want to do it around the source code and have enforced boundaries within the sources. And then there's an aspect of you want to be able to do binary componentization, so for binary integration, where I take an existing binary component from someone and bring it into my product and use it. And the solutions for those two things are different. And so we'll come back and talk about those, okay? Now, I have my set of, I had a 3+, I've now grown it out to 4, my acid tests for do I think we've accomplished our goals in an engineering system. So think about the goals for one engineering system, what we want to accomplish. These 4 questions kind of summarize to me if we've succeeded or not. And if we can answer these questions in the positive, then I assert we will have a much better engineering system than we don't. If we can't answer these questions in the positive, then we have problems, or we still have the same problems that we had today, okay? And to me, it's a driver as we think about, oppositely, myself and my set of reports. When we every day come into work and say, what should we be working on today? I ask these questions. Well, what can we do today that's going to help improve one of these things? Or, if we're doing something, is it really going to help these? So the first one is, can I find in the list any source, in the source for any component in the company, And then I have this little phrase at the end, without sending an email. And what I mean by that is without having to invoke another human in order to answer that question. So I've got a piece of code, I've got a binary, for example. Let's say I'm running Outlook. Well, where do I find how can I find the source code for Outlook, and how can I get it onto my machines or get it to a place where I can look at it? And can I do that without invoking human beings? All right. The next one is, well, let's say I did get that source code for Outlook, and I decided that the schedule view in Outlook is not very good for scheduling a reoccurring meeting. That really what I want is a view that kind of shows me my entire week and darker areas where there's commitments across that time frame, across the entire, on Mondays at 9 a.m. show that's a busy time in my calendar across all my weeks, but other times in the day show that they're not busy. Okay, let's just say I want to do that, add that feature into Outlook because it would be really useful to me. And I realize the Outlook team doesn't care because it's not that important to them. Well, can I go make the set of code changes to add that feature into Outlook, build it, verify that I haven't broken anything in Outlook because I can run all of their RI gates, and flight it to, say, my buddies and say, hey, I added this thing to Outlook. Why don't you try it, see if it works, and see how you like it, okay? Can I do that without invoking all of those steps without invoking other humans, okay? That would be a very powerful engineering system. Next one is, well, can I commit my changes to a discoverable branch? So I made this set of changes to Outlook. Can I, instead of having them just sit on my desk, can I put them up near, say in the Outlook, in the source repo or depot that Outlook is using, maybe in a branch, okay, but where someone else can find it if they want to look at it. And I can share my code with someone else. And can I submit a pull request? And a pull request means, can I submit a BB pack essentially, but a more formal mechanism to the developers of Outlook and expect them to actually be able to look at it and maybe look at what my reputation is for my code quality and the flighting results to see how well it worked for people in the flighting results, and actually even expect them to accept that set of changes. Yes, question.
Finish your point. I have a question.
Okay, so and there's clearly a tension here between where the Outlook team wants to take Outlook and what I've done this feature, and there's tensions there. But if it's something they say, oh, can we get to a place where the culture is, oh, this is something other people would use, we can see how to, we'll take it, okay? And because I've done all their RIs and I've done all their processes and everything else. And, this is one of the goodnesses that happens in the OSS community is people see something they want to change and they have an ability to change it. Inside Microsoft right now, what we find is we all see things that we want to change and we can't change them, and instead we just get frustrated, okay? And then I'll do the last point, and then I'll come back to your question. Can I, let's say I have a service or a product, can I take someone else's component, bring it into my product with servicing and have it maintained over a long time? And my counterexample I always give of this is the ribbon that was developed in Office and brought into Windows in Windows 7, and it was brought in by forking it in such a way that the two, it might as well be a completely different code base. The two things are never going to see each other and never going to share any benefits from each other ever again. And this is, there are many reasons why we do this as part of a culture, but it's something that fundamentally, partly because we don't have the right tools to support it, partly because we have aspects of our culture, but it's something that needs to change. Now your question.
So, as you picked Outlook as your example, I'm a dev. I've been in the Outlook team for a year and a half.
Fantastic. All right.
I can't do any of those things.
What?
And I'm on the team.
You what?
I can't do any of those things.
Ah.
And I'm on the team. So when I first saw this list of asset tests, my mind went to, I think later you're going to get to a computer readable description of a component that includes information for all this, which is, a huge problem that would be great to solve. But part of the reason I can't do any of those things without invoking a human is the 20-odd years that people have been working on Outlook, not following what we now know are best practices around software engineering. And it's just an opaque tangle of code. So do you have plans or ideas or aspirations to address that? Because even if I had a lot of the tools that I see being described here and on the RTL, I still can't understand.
Can't solve. Yes. Okay. So let me see if I can summarize that question. Okay. So, point is, even if I'm a member of the Outlook team, it's really hard to do any of these. It's not just because you're not part. We fail the acid test not just because I'm outside of the Outlook test. We fail them because even inside, we still have a lot of human processes, and also the code. We have a lot of debt around the code, test debt, description debt, other things that, and entangled code that you can't do that very well. And so, are there things we can do with the untangled? And so, yes, when I talk about the source partitioning, part of that is there are two things. There's a cultural aspect that has to change about the way we work, and then there are, I think there's some tooling work changes we can help make that. And I'll come back and talk about source partition. When I come back to that slide again about the tools, and I talk about source partition, make sure I talk about that a little bit more. Okay. But anyway, so I guess the question that makes me feel good is there anyone who says, oh, I think the answer to these questions should be no? Okay? All right. We're all in agreement. Great. Okay, let's just do it then. Okay? Act 2. I prepared this deck as a 3-act play. Oh, no! Okay, Mike, I don't care about you, man. All right, I'm just being flippant. All right. Well, Mike, you should send me your list of questions and which ones you disagree with. I'd like to know. Okay, to Mike's point, if he didn't agree. So, Act 2. This is a 3-part play. And anybody who knows anything about 3-part plays is the second one is the dark one. Okay, that's when all hell breaks loose and everything goes bad, right? It's also usually where the most excitement and tension is. Okay, so which is one of the things I think needs to happen is we need to innovate The Empire Strikes Back. Exactly, The Empire Strikes Back, my favorite one. Which is why should we do an engineering system? Okay, because one of the things, if we're changing the engineering system, it affects everybody. Okay, I don't think this was more visible to me about how everybody this affects until we were having discussions within the engineering leadership team, engineering system leadership team, and we got talking about changing from Product Studio to TFS. And the PMs in the room, the GPMs and PM leads said, no way can we do that. That's too hard. It touches too many things. And I appreciated this irony between the devs who are just completely, everybody's been up in arm about we're going to change to use Git, okay? Because the devs know how viscerally how much change that is going to affect on them. And the PMs were totally willing to inflict changing Git on the devs. But the PMs were not willing to inflict changing from Product Studio to TFS for work item tracking on themselves, okay? And it's because they finally realized how big of a change that was to them. And I just point out, yes, it's the same change. Okay, it's a lot of change. And do we really want to do it? And do we really care? And so that's why I go back to the why. Why is we want to change? Well, what does the business need from the engineering system? What the business needs from the engineering system is that we are delivering more value more quickly to more customers. Okay. So, and there's 2 vectors that we really want to, the engineering system can change. One of them is the time to deployment. So how long it takes me to get a line of code and get it deployed into a product or deployed in a service. The engineering system affects that. And we want to drive that number as low as we possibly can. The other axis is the fully loaded cost. Okay. So that, how much it costs for the dev to write the code, for all the different processes that are involved in moving from that line of code to deployed product where humans are involved, all of that fully burdened loaded cost, that needs to shrink as well, okay? And by shrinking those 2 things and driving those down for, whether it's a line of code or a feature or a product and service, then that will allow us to generate more value, more in less time, so more quickly, and ideally be able to also address, if we can address more products and services, more features, we can address more customers and grow the customer base as well. So that's all the business needs. It just needs us to generate more money by pushing these 2 arrows just the right direction. Okay, and the engineering system has not been doing that. Okay, and I have these. I call these the 6 slides of doom. General at this point. Okay, so what I ask is everyone online, please raise your hand, and everyone in the room, please raise your hand. Say, I will not quit after I've seen these 6 slides. Okay? All right, I'm seeing some hands not up, okay? Okay. Maybe you were planning on quitting already, so you didn't think, okay. When I gave the first talk, Dave Probert didn't raise his hand, and somebody pointed that out, and I said, that's because Dave's a curmudgeon. He's just going to retire before I inflict any of this on him. But anyway, okay, so to illustrate this, what the engineering system, okay, so this is the first year of smartphone. It's the first year of Android stacked against the first year of Windows Phone 7 stacked against the first year of iPhone. And the thing that it illustrates is we actually did really good in the first year of Windows 7, that we sold as many units roughly as either of these two competitors in their first year, okay? In fact, things looked so good that this is actual numeric prediction from IDC, the quotes from Gartner. Both IDC and Gartner predicted that Windows Phone would match iPhone, in fact, surpass iPhone in market sales per quarter by the end of next year, and that our cumulative 2-year run of machines deployed would approach them as well. Okay, so they were predicting we were going to do well in this market, that we would be a third party in the market, but that we would do well and have a competitive position in the market. Okay, so let's jump out actually to what's actually happened in the 2 years since those predictions were made. And first thing I point out is they were actually very good at predicting how many units iPhone. Because one thing you might say is, you predict the future, you're only so good. Okay, they're actually pretty darn good at predicting how many units of iPhone we're going to ship over the next 2 years. Okay, so they're not completely pulling numbers out of their rear ends. Okay. The other thing, though, is you look at the difference between predicted and actual for Windows Phone and for Android. Okay, and two things happened. Well, Android took off even more than IDC or Gartner were willing to predict, and phone didn't. Okay, and my simple explanation of why they were so far off in these predictions is that, well, what they didn't factor in making the predictions was network effect. Okay, network effect is it's very simple. The more people that have a device that runs the same applications, the more applications there are for that device, and so therefore the more valuable that device becomes because it has more applications. So therefore more people buy that device. Okay, and the network effect that Android gets is huge, and particularly it's a two-sided network effect, and it's very hard for us to overcome, either getting enough applications that our platform is compelling, as valuable to customers as Android does, and vice versa, having enough customers so that people bring the applications to Windows Phone. And we haven't, anyway. And a good simple way to describe it is, you imagine you have a phone that is the same physical device that will either boot into Android or boot into Windows Phone. When it's booted into Android, it's more valuable to you because there are more applications that you want on it. Is basically what it comes down to. And both IDC and Gartner really wanted us to win, and they wanted to give us the benefit of the doubt, and kind of ignored that impact. Okay, and it's big. All right. Now, let's talk about. So I've put the Windows Phone timeline on here just so you can see kind of our cadence. And now let's throw iPhone on here. Okay, so one of the things I always like to talk about here is iPhone. It's huge, right? I mean, it's completely changed what computing was, the smartphone when they invented it. And one of the things I first want to point out is sometimes we might want to beat ourselves up because we didn't produce iPhone before Apple did. This compelling touch, capacitive touch, very natural user interface, the whole concept of what a smartphone would look like. We didn't invent it first, and that was a leadership failure. Okay, let's just admit it for what it is. It was a leadership failure. And when I say a leadership failure, what I mean is we knew about capacitive touch. We knew when it was going to be practical on the phones. We knew what the curves looked like in terms of when the phones would have certain performances, etc. We actually knew about pinch and zoom, and yet we didn't produce the iPhone. It's because we had this other thing called Windows Mobile that wanted to pretend it was looking like a desktop, and anyway, almost never in this company have we been a good first mover into an area. And it's because I'll come back to it, culture, but it's because we get into an area and we don't learn. We have an opinion and we project an opinion, and then we don't gather enough data to find out where our opinion is wrong and quickly adapt. Okay, so as a result, we get into a market and we just kind of stagnate there. If you look at what mobile did from beginning to end, before Windows Phone, it was very much that. Got a market and we stagnated. We've done it over and over again in very many other fields. Frank Shaw has a great slide that actually lists all the places where we've done this. Okay, but traditionally where Microsoft has excelled is as a first follower. Okay, and so the other point I mentioned is on this calendar. So in the end of 2007, beginning of 2008, I was doing a research project in the phone space, and we were out talking to chipset vendors and carriers and other people about hardware and other things. And they were basically, at that point, they were desperate. If you were not AT&T and you were a carrier in the United States, you would do absolutely anything to have a device that would compete with iPhone, because you couldn't have iPhone because AT&T had a lock on it. Okay, and if you had a chip other than the chip that was being used in the iPhone, you would do anything to have a device using your chip that was able to compete with this thing. Okay, and that story across the entire world, these people were hungry. They would have done absolutely anything. Whatever the year before, if you would have gone to Verizon or T-Mobile or somebody, and in 2006 and said, I'm going to have a device, but you're going to have to do these things. You're going to have to let me sell apps directly to the customer. You're going to do these things. They might have told you, forget it. It's not going to work. In late 2007, early 2008, you could have told them anything you wanted. You're going to have to paint all your employees blue for the next 5 years. They say, yes, we'll do it. Okay, anything, absolutely anything. And in fact, Android and the Android guides took advantage of that. Okay. And I will point out, the Android team was already working before 2007. They were not working on something that looked like Android or looked like iPhone. They were looking at building a completely different phone. But as soon as they saw the iPhone, they said, oh my gosh, we have to compete with that. That's what the world looks like. And so they pivot the ship. They shipped Android 1.0 in 2008, late 2008. And then they had this cadence of nearly a release a quarter for a very long time. And one of the things I'll point out, you'll notice we get in the last 2 years, the cadence appears to slow down of the Android releases. That's deceptive. They haven't slowed down. What's happened is they figured out how to, they can now upgrade almost all of the features of the platform without upgrading the platform itself. Okay, and so they don't have to do a full release very frequently, but they can be rapidly releasing new features on top of that. And so they just don't have to upgrade the base platform that frequently. Okay, so in fact, it looks like they've slowed down. They've actually sped up. They're actually on some of these things cadences of weeks and months kind of thing. And the way I will describe this, that Android curve, that should have been us. Okay, everything they did, the way they've targeted the low end, the way they've opened up their platform, that was all classic Microsoft play. It was exactly what Microsoft has always done in field. And we just failed to do it this time. You ask, well, why did we fail to do it? Problem was we had accumulated a huge engineering debt and we couldn't overcome it. Okay, and in fact, one of the things I'll point out is the Windows Phone 8, okay, which is almost 6 years after iPhone, is when we finally shipped a converged operating system, okay, where we use the same operating system across all our devices, which was exactly what Apple did when they shipped iPhone. They shipped a converged operating system, okay? And I really, one of the things I want to make very clear, this is not a failure of the phone engineers, okay? What the phone engineers have done in the last 5 years is absolutely amazing to me, particularly given the engineering system that they had to fight against. But it is an indication of how hard it was to move our engineering system and how hard we just, not able to move on the cadence that we have to move on anymore. The exact same set of things happen in the tablet market, where our share is very, very small because the other people have gotten in and they've moved much more aggressively than we've been able to move. Okay, again. And then my last slide of doom is other areas where you see where either we have gotten in and then failed to move, or we've never even really been able to compete. So other areas where, because our engineering system has prohibited us from generating new products and evolving new products very quickly, where we've had a very hard time competing. Okay, and some of these I think are really, really scary. Okay, but okay, so that's my end of my 6 slides of doom. And one of the things I always have to say is, okay, so that's the end of Act 2. You're all feeling very depressed, right? Luke has just found out that Darth Vader's his father, et cetera, et cetera. Had his hand cut off, all those kind of things. That is very depressing, okay? But you all knew this, okay? I don't think there's anyone in this room or on the link call that today just found out that we don't have incredible phone share. Okay, that was not a shock to anybody. Okay, and you all knew it. And I think that's an important thing to remember. Is I may have presented the data in a more compelling manner than you've seen it presented, or not, but you knew it, and there was still a reason why you're here. Okay, and I had this data, and I had these slides before anybody else had, and I didn't quit before I managed to present them. And there's a couple of reasons. One of them is I come to work at Microsoft because I have a group of people that I work with who I really enjoy working with, and who I very value what they can do and what I am able to do when I work with them. Okay, and you do too, which is one of the factors why you come to work. Another one is that, well, we're actually an extremely well-funded startup. If you look at that, I mean, we're behind, we've got the problems, but we've got a lot of money in the bank, and we still have ways that we know how to make money. And we also have a leadership that recognizes that we have problems and is trying to do something about this. And to me, you've got a winning team, a team that has won in the past and knows how to win, a team that knows how to execute, and management, etc. You believe in, well, then there's no place to go but up. And that's what this really is about, is there's no place to go from up, so let's just go do it. All right, so Act 3, cultural change. One of the things, in fact, one of my most vocal critics of vocal, but he sent it all directly to me instead of sharing it online, about building a new engineering system and doing one engineering system is Brian Tuttle. I don't know if any of you know Brian, old Windows guy. I worked with him in Azure. I very much like value his input, but he's been very critical of what we're doing with the engineering system, and partly he's very critical. One, because he looks at things very critically and really wants to make sure we do the best possible thing. The other thing is, he says, talking about changing the tools it's a red herring. Real problem is not the tools. The real problem is the culture, okay, and how we act around those tools. And my response to that is, yes, he's right, partly right. And what I mean by that is cultures develop around tools. And so one of the reasons we're trying to change the tools is, well, the tools, we should be able to do better things with the tools, okay? And changing the tools so that the tools are no longer the excuse will help us focus on the culture. But we do fundamentally have to change the culture. And that's actually why I'm giving these talks and I will talk to every single person at Microsoft individually if I have to, is to get out the message that, yes, we should embrace better tools, but we should also think about the culture. And each of you individually is responsible for helping set the culture and making the culture be whatever it's going to be, okay? All right, let's see. Sometimes this video, all right, I have okay, it came up before. I can do okay, I'm going to share the desktop here since okay. And I've got a video that I want to show. Okay, so this video is 2 pit stops. It takes a while to change tires. Yeah, 67 seconds, yes. Now we'll see one from 2013. Okay, did you miss that? Okay, now in slow-mo, because it was that fast. Okay, all right. Let me go back here to the probably. I'm going to try. Okay. Now the videos. Okay. All right. Okay. So a couple of things I love to point out of this. One of them, remember when he was scrubbing or wiping the windshield at the very end? It took more than 3 seconds to wipe the windshield at the very end in 1950. Okay, and it took 3 seconds to do the entire thing. I must have watched, when I first got this video, I must have watched it 40 times in slow-mo, watching them change those 4 tires and figuring out how they did it and everything. Next thing I'll point out, there are 3, if you look very carefully, you'll see that there's only 3 technical innovations between 1950 and 2013 in how you do a pit stop. Okay, one of the technical innovations is the pneumatic wrenches. Okay, so instead of having to use the hammer to whale on the nut to get the wheel off, you use the pneumatic wrench. Okay, so that's one technical innovation. And actually, I was going to go check. I've got to believe that they must have known how to do pneumatic wrenches close to 1950. Okay. The second technical innovation was the pneumatic lift. Okay, which the guy in the front of the car is using to lift and importantly, when he lets down, he's got a pneumatic control to let it down. The third technical innovation that I could see is the plexiglass. So we don't have to spend 3 seconds wiping the windshield in front of the driver. The driver can actually wipe his own windshield if he has to. He can, okay. That's it. That's the only technical innovation. Now imagine you take those 3 technical innovations, you time travel back to 1949, and give them to Holland's pit crew. How fast is their pit stop going to be? My guess is their pit stop's going to be about 50 seconds instead of 67 seconds. Okay. Because you still got one guy changing the tire and then going around it, and yes, he can do it fast. The important thing is what the key innovation is not the tools. It was about how you use those tools. Okay, and you organize the people. I think one of the important things about thinking about this process, there's a lot of people standing around the car. More important than what each person does is that each person knows what not to do, whose way not to get in front of them. And the one I'll use as the key example of this is the guy with the pneumatic pump that raises the car up. If you watch, well, you can see on the clip right there, you'll notice he's not in front of the car. He was in front of the car when the car came in. When the car leaves, he is over off the side. He's lifted the car, and actually as he was lifting the car, he's already moves so that he's out of the way of the car, so that when he lets the car down, he can spin the hydraulic pump out of the way so that he's not in the driver's way and he's not impeding the driver's progress. And the whole thing about the process here is about how do I make it so that other people can be empowered and I'm out of their way, etc. And that was the powerful innovation that happens there. Now, you go back and think about process at Microsoft and how we build software and how we engage around our engineering system. How often in your daily work do you think about how you can most rapidly get out of someone else's way so that they can be effective? One way to look at it. Okay, so let's talk about. I want to identify 3 key areas where I think where we fundamentally have to have changes in our processes and in our culture. One of them is prioritizing responsiveness and not information arbitrage. You probably haven't heard this term before because I coined it. Well, I grabbed it from somebody who hadn't intended to coin it a few weeks back. Information arbitrage. So arbitrage is making profit in a commodities market by inequalities in a commodity market. So like if in gasoline, for example, or oil, if you can buy oil cheaper where it's cheaper one place and take it to someplace else where you can sell it for more money, that's arbitrage. Okay, it's a way of generating value by inequalities inefficiencies in markets. Okay, well, information arbitrage is actually a very fundamental aspect of not only how Microsoft has done business, but how many businesses in whatever line of business they are have operated. And this is generating value because I know something that somebody doesn't else know, or because I've controlled the information flow. Tenting is a very important way that one executes information arbitrage, for example. Okay, we have had a culture very much oriented around people at the top know things, people down at the bottom don't know things. Or there's many different ways you can think about information arbitrage. One of the ways I can put it, one form of information arbitrage we often engage in individually is, if you don't know about my mistakes or where I'm wrong, you can't take advantage of that. Okay, and so I protect that information. I try not to disclose as rapidly as possible what my mistakes are or where I'm wrong. Okay, that is a form of information arbitrage. But the alternative that we want to really strive toward is responsiveness. So this is making information flow as quickly as possible to everyone and allowing people to experiment so that they're actually reducing the inequalities in the market because they're actually experimenting and trying new things out. The way I describe this in our culture is we should strive to learn we should strive to learn instead of strive to be right. Okay. The other one is autonomy, allowing other people to act efficiently, and then transparency, sharing information as rapidly as possible.
I had a question on the first side, though.
Yes.
If you were to say planning, control, and secrecy, the first thing I think of is Apple.
Yes.
So is their culture broken, or are they just doing planning, control, and secrecy different than we were doing it?
This is a really good question because this does seem to be very much Apple's model. A good way to describe it is, my hypothesis is that works fantastic if you've got a one-in-a-generation genius. Okay? And if you don't have a one-in-a-generation genius, it doesn't work. And it's not clear that it works over the long term either. Okay. And I think anyway. Yeah. Okay. All right. The second one is I'll put it this way: prioritizing automation, not bureaucracy. I use the word bureaucracy here to mean human processes. And the way it's defining automation is use of machines to free humans for more meaningful pursuits. People are very expensive. A fully burdened Microsoft employee, this is actually a low number, but it's a convenient number to use, is the fully burdened cost of a Microsoft employee is about $250,000 a year. Okay, the fully burdened cost of a computer, even a relatively large server, is about $2,500 a year. Okay, $2,500 a year. That's a big disparity. It's 2 orders of magnitude, and we don't take advantage of it often enough. So we shouldn't use people when machines are needed, and it should be this should be just natural to us. We use computers all the time. We should always think about, how can I automate this? How can I make it so the computer is the decision point instead of a human being the decision point? And just some illustrations to put this in perspective. So a 1 hour build branch delay of a team of about 50 people has a cost of $6,000. Okay, every time it happens. So it doesn't have to happen very many times when, well, gee, you should have just bought some more build machines, for example, and done that. This is the next one, the 1 minute delay in SD sync. Anybody been trying to sync SDK tools recently? Okay, we've had some serious issues within the Windows organization around our source depots. And bless his heart, Jared Green talked to MSIT and convinced them we're getting all new servers to do our source depot servers. Anybody want to guess how old the machines were that were running our Source Depot? 8 years. Okay. The cost to upgrade those machines, this is probably confidential information, probably shouldn't disclose it in this form, but anyway, the cost to upgrade all those machines was about $100,000. Okay. Now, a 1 minute delay in SD sync time. My estimate is that it's about if you figure that you sync about 200 times a year, and let's say sync takes 1 minute longer than it would need to, well, that's only $2 million. Okay. My point to Jared when I discussed this was, Jared, you should not have even had to have that meeting to upgrade those machines. It's just obvious. It's cheaper to just upgrade the machines. You don't even have the meeting on that one. Okay. The enlistment process gated by human approval. This is, okay, so you think about, in order to get someone else's source code, I have to go through a RAM web or an ID web, some place and get a permission. Some human has to approve that permission. Let's say they instantaneously approve it. There's still a delay for that to propagate through the AD servers because I had it so that a human had to make that decision. And let's say that you do that a seventh of our developers do that during the course of the year. That means it costs us about $5 million because we put that restriction on. Now you ask, if we took all those restrictions off entirely, what would be the cost to the organization? What's the maximum risk exposure we have of someone having access to some source code that they shouldn't have? Okay. It's a different way to think about things. And my last one is how much the Windows planning process costs. Okay. And whether we get enough value. So
we're 60 minutes in.
Yes, I know. I've been long-winded. Anyway. And then the last one I want to talk about was prioritizing componentization. This is getting back to the thing about our code bases are very big and they're intertwined together. Componentization is breaking the code into discrete units of functionality with well-defined interfaces. And there's two reasons you want to do componentization. One of them is managing complexity. If you draw a boundary and allow people to hold implementation private on one side of the boundary and have a well-defined interface on the other side of that boundary, that allows people to compartmentalize complexity and manage complexity. Now, that's not the same. So you can still have transparency. You can still let people see source code things. But it's to manage complexity and also enable reuse. And this one has not typically been a really strong aspect of our culture, but is something that I think we very much need to do. And my evaluation, so I've got these two questions down at the bottom, are kind of statements. I would almost put these on the MS poll, if we evaluate how well we're doing componentization is, do I feel I'm valued as a PM when I eliminate dependencies between other teams, between teams, and as a developer, do I feel valued when I enhance and use someone else's component instead of building my own, okay, and making that possible? Yes, sir.
You did the same thing on the previous slide, and your slide mentions the test.
What?
You have a similar thing on the previous slide.
Yeah, I just put.
But neither slide mentions.
Oh yeah. Yeah. Okay, so you point out I don't mention test. You're right. I just couldn't think of what the example was. If you've got some good suggestions for good examples, what the statement ought to be. Okay. Yeah, I'll take it. And then I just want to, okay, cultural change is hard, tool change is hard. Well. What's going on? Okay. But in an evolving world with accruing debt, which is the world we live in, the most dangerous thing we could do is to not change anything at all. And that's why we need to try to change things. And, go back to the set of changes that we're talking about. Are they the right changes? One of the questions you should ask. Well, yes, it is a question we should ask. And what we should be doing, my assertion is they're probably not all the right answers. And what we should do is figure out how to explore in the answers and do an experiment in the answer, and then do feedback and figure out how to iterate and improve this. And that's what we should do. Okay, now, yeah, questions, whatever the questions you got.
So
yes,
I asked a question the first time the slide came up, so I was getting it.
Okay.
Any idea about how we got to where we are? I mean, certainly you mentioned, and I totally agree, we need to look at our systems in place, build new systems, change the way we work and things like that. No argument there. My only concern, as you mentioned, is we have a history of a company of sort of either going status quo or perhaps seeing others do something and say, hey, we should do that as well. And it seems like there's some parallels happening here. Would you agree, disagree, and furthermore, what prevents us from, saying, well, even maybe a bit of the not invented here syndrome, where, well, we can build better than anyone else, and we'll just build all these new tools, and it'll be the solution to all of our problems.
Yeah. Well, can I summarize the point? Your question is, if I look at the cultural changes you say we need to, aren't we repeating those same cultural mistakes in the engineering system? Would that be the really blunt way, or what prevents us from doing that? I do worry that we are repeating some of the same cultural mistakes, and I think what that emphasizes, even being very conscious of what the cultural changes are we need to do, it is hard to change one's daily habits. And I guess my response on that is, when you see those, we owe it to each other to call those out and say, hey, I think maybe you're doing a little too much not invented here, and we should try to change it. I mean, I think the one, okay, like Git, for example, we're not doing a not invented here. We just said, hey, we need DVCS. Someone outside of Microsoft has figured out how to do DVCS very well, and we're going to take that and leverage it. NuGet is another case where there's a set of technology which say, hey, this works pretty well, let's just figure out how to bring it in. The one case where we clearly haven't done that is Domino, where we clearly inventing things for ourselves. And for that very purpose, it is perhaps one of the things I'm most concerned about of the engineering system, because the signs are that when we when we don't learn from others and we don't try to learn and iterate fast enough, we're going to have problems. So all of my emphasis in terms of trying to help work with the Domino team is how do we accelerate their learning and their experimentation, try to help them do that.
To what extent? So I hear the term one bandied about quite a bit. One this, one that, one blah blah blah.
It's the new .NET, man.
Sounds like one pony, one sled. I mean, and the sleds we're trying to pull multiple sleds, different operating systems. Are we really trying to create one engineering system, or are we trying to create a heterogeneous engineering system, an ecosystem that works for all the different sleds we need to pull?
Well, I would say certainly the risk at Microsoft is that we will try to create one engineering system that works end-to-end for everyone, and it won't work so well, right? This is going back to the componentization. What we really should be doing is individual pieces that you use and plug and play and replace or do whatever you have to do, and hopefully the best piece in each case wins out. And we are trying to do that, trying to break it up. And one of the ways we're trying to break it up, I made some vague promises in the abstract for this talk that I talked a little bit about timelines and schedules and things, or status and where we're going. One of the things that we have definitely learned in the last 3 months and are making adjustments on is that each of these things, each of these 5 tool areas needs to move independently and needs to be separable enough from the others that we can make forward progress on it and teams can adapt and use pieces of it independent of when the other ones happen, right? So for example, the changes that we're source componentization. We have an effort, a technology we call source partitioning, that we're getting ready to the tooling will actually be into Windows, the tools to do this in another 3 weeks. For a way that allows us to do source draw boundaries around the pieces of the code, say this is a partition, and be able to declare what the interfaces are between that and the rest of the code base and have them enforced by build.exe before we get to Domino, before we get to Get, as a way to allow, to start accruing benefits. So we're trying to allow us to accrue a benefit as much as we can individually, because componentization says I should make separable pieces so that I can manage my complexity.
Will we be able to use Domino in conjunction with Pizza Hut? I mean, what if there's another build language?
Pizza Hut as opposed to Papa John's? I didn't know.
I'm trying to find an analogy, right? So we got different kinds of pizza. We all like pizza, but we don't all like Domino's.
Oh, you're far too subtle for me on that question. All right.
So to what extent are we going to be allow heterogeneity in some of the core pieces so that we can mix and match things as we find?
Yeah, well, I will say, so this question about heterogeneous and how much diversity do we allow in the product, there's an inherent tension here, which is you want to use the right tool for your group, right? And maybe, tool X is better than tool Y for that. But there's also a tension of if everybody uses the same tools, we get a network effect with developer experience. We get a network effect of, I can go to any team's code base and I know how to operate within their code base because, their build works the same and their source control works the same and everything else. There's also tension of, well, at some point, whatever build language we have, we know that at some point down the road, be it 10 years or 50 or 5, someone will come up with a better build system, and we're going to need to evolve. I guess good was, I don't think we figured out what the right way to address that tension is. The only way we figured out how to address that tension right now is instead of trying to do a big bang, we're all on the old engineering system, and then 8 or 80 weeks from now, we're all on the new engineering system, is just try to make the individual pieces be roll-outable by themselves. So I think you should be able to use Domino, say, without Git, for example, or without source partition, that each of those is.
Okay.
Oh, okay. So, Galen, we're getting a lot of questions about roadmap.
Good.
So what's going to be ready when, and who's going to be using it when? And I think George is here, and he knows a lot about that.
All right, George. All right. All right. I will talk about a couple of key roadmaps. So the first one is the beginning of M1. Okay, so OSG's M1. At the beginning of M1, we intend to roll out source componentization. We've already made an ask up through all the dev directors that that for each dev manager that they assign one of their engineers to be what we call a partitioning champion for their team to work with us on putting in source partitions into place for those teams, with the idea that by the time we got to the end of M1 that we would actually have source componentization in the OSG code base and actually enforced across the entire code base. Okay. That I don't have any idea. Okay.
Is it like a month or 6 months?
Oh, for when? For someone like, say, an Office, for example, I would not expect until the beginning of your next ship cycle would you guys be picking up some.
No, I get that. I'm just like, you said that you're going to have source components by the end of it, but I have no idea what that is.
Date. Is that August?
12 weeks.
Yeah, 12 weeks. So it starts in the 19th, right? Anyway, so 12 weeks. Okay, 13 weeks. The other thing that we will start rolling out in M1 is Domino. So we're doing some automatic conversion of some of the projects, and going to also invite some early teams that are interested in early adopting to try expressing their build in Domino. I guess a good way to describe it, my realistic expectation, the team doing Domino probably might not agree with my timing on this, is that by the end of the M1, we hope that we have that Domino understands all of the tools that we use in the OSG build process, and that some percentage of the projects that are in Windows, we've experimented and tried to build them with Domino. And the way they would describe this is there's approximately 35,000 projects in Windows, build projects in Windows, and they believe that by the end of M1, they could experiment with building roughly 10,000 of those inside of Domino. And then the next, at the end of M2, which would be roughly the end of this calendar year, that we can actually build all of Windows in Domino. Now, whether we've flipped the developers over so that they're building in Domino or whether we're doing it on the side, we haven't quite figured that one out. And that the source componentization, there's a step after you do initial source where you apply boundaries, but we have an exception mechanism for legacy dependencies, and we'll remove all of those during M2. Git, we do not have a timeline yet for when we're going to adopt Git. I think what we're shooting for is that threshold +1. As we move from threshold to threshold +1, that's when we implement Git across all of OSG. But there's still some very open questions about that. One of I talk about the partnership between OSG and DevDiv. Brian Harry's org, in particular the TFS VSO organization, they have taken their code base and split it up into a bunch of Git repos, and everyone who is concerned about Git says, oh, that's going to be painful for Windows. Yes, it's going to be painful for us. It was, well, at least it was very painful for them, and they're going through and we're figuring out what tooling we need and how to make that work. So I guess a good way to describe it. During M1, DevDiv is doing a very self-inflicted experiment to figure out what we're going to do with Git and how we will scale it out, with hope that, say, by the end of M2 we have a plan of when we'll move.
Can I pile on a little?
What?
Can I pile on a little bit?
Sure, go ahead, George.
So
Come stand close to the mic, George.
All right. So I'm running onboarding for OSG, and it's a huge challenge because saying no is really hard. But saying no is really important because if we don't say no to a lot of things at this point, it'd be easy for our small team to capsize under all of the support requests that would generate. So I think the thing that Galen said, I think, is most important for understanding how or why we want to roll out, is that we want to make sure that every time we roll out to a new set of customers, we have opportunities to learn and opportunities to not make the same mistakes that we made last time. And we want that to kind of control the speed of rollout. And something else that's really important is that the idea that we could roll out, for example, source componentization without rolling out a new source code management system. I think, just to speak to Git in particular, a lot of the things that make Git great are awesome when you're working on a componentized set of software or things that you're working with. They are awful and terrible, and you should not try it with a giant, homogeneous code base. So we want to make very clear that we want to get ways of working, and we want to make your lives easier as soon as possible. Part of that is being very selective about what we focus on and what we roll out, so that there's not a bunch of chaos when we do roll out. We have, billion-dollar businesses all over Microsoft, and we don't want to take the risk of sinking one of them because of new things that we're working with. We want to roll out things that we've learned and have proven are successful, and teams want to adopt, instead of things that are, hey, everybody in Microsoft, use this now, and even if you suffer, we want it to be an enjoyable improvement to your lives, not something that's jammed down your throats.
So for both of you, people are asking basically what the product teams can do to prepare for this transition, and also looking for any other early adopters.
You answer that.
Yeah. So we are looking for early adopters. We're always looking for people who are willing to take some pain for other people. And we've also, like in the design review process, one of the things we've done is we pull in representatives from any of the other divisions so that we kind of control things there. Hold on, there was a question in early adopters. What was the other question?
What they can do to prepare for this transition.
What they can do.
To Apex.
What? Componentize. Well, so one of the things they can do is literally the very first thing that we're going to roll out is a source partitioning in OSG. And one of the first things we like people do is pick up that and start componentizing their code, start drawing the partition boundaries around the code, figuring out where the boundaries are between the code that your team works on and other teams, and where are you going to draw a boundary, which interfaces you want to be public interfaces, which and private, and who should be your friends in the C++ version of the word friends, and deploying the source componentization is one of the first things, because a lot of the rest of this kind of falls out, or, George said, Git will be a lot easier when we have the code base componentized, and as we think about that, for example.